Once again, welcome everyone. We're starting now our talks. And the first talk of the day is HDFQL, the easy way to manage HDF5 data. Gert Hieber, my colleague, will be presenting for our collaborator week, Mr. HDFQL, as he likes to call himself. So Gert, please.
Okay, well, thank you for the opportunity to present here today. I cannot take credit for any of the work and not even the slides. All of that was done by Rick. And yeah, it's a shame that he can't be here today, but he asked me to present this on his behalf, and I'll try to do as good as an impersonation as I can. Okay, it's about HDFQL, the easy way to manage HDF data, and we'll be talking about what it is, who's using it, how it works, give you some examples, talk about some of the HDF features that are supported in HDFQL, and what's sort of on the drawing board, what's coming next. And there's quite a bit to talk about there. Okay, what is HDFQL? The name is, I think, very suggestive. It's a query language for the hierarchical data format version 5, HDF5. And it is a high-level language, as you would suspect when you hear query language. And most importantly, it is a declarative language. So unlike sort of traditional imperative languages where you as the developer pretty much dictate what happens step by step in a way, for declarative languages, you kind of specify the goal, what you would like to achieve, but you don't really control in great detail sort of the mechanics of how you get to that goal, how you achieve the, in this case, data management tasks. And of course, the gold standard in that domain is SQL, the structured query language. And I'm sure you can all sort of sympathize with the idea that plain SQL or relational SQL is not quite enough to make you very productive with HDF5. And so what Rick chose to do was to basically augment and extend SQL where necessary to just deal with HDF5, with the groups and attributes and all those kinds of things that are not really there in the relational model. And sure, you can argue right there and say, well, is it some kind of international standard, or no, it's not. It's really, he made it up. My personal opinion is he did this in a very skillful way. And yeah, he makes no claim that this is going to be an ISO standard or something like that. But I think he made some very good choices that for you as a user give you that sort of boost in productivity. And of course, on the upside, this dramatically reduces the learning effort and the time to get your head around HDF5, especially if you are coming sort of more from a database-like background. I think approaching HDF5 through HDFQL may turn out to be very easy and rewarding quickly. And of course, yeah, at the end of the day, you will have more time to focus on solving your problem rather than sort of understanding the sort of esoteric aspect, some of the esoteric aspects of HDF5. Then you might say, okay, that's a query language, that's great, but how do I actually get stuff done with it? In other words, is this more like a REPL thing, sort of read, evaluate, print, or shell type environment where you type these queries and then things just happen? That would be fine. But then, of course, if you want to use this in applications, how does that really, how do you embed a language or get a language into another host language? And that host language could be C or C# or Java or R or something like that. So you have the way Rick chose to implement that is really with this pair of languages where HDFQL is that guest language. And in these different host languages that he supports, and I have a list later, you use the same guest language to express your data management tasks. And then there is typically a construct, a primitive, a module, depending on what the modularization capability in that host language is, that basically can be used to execute HDFQL queries. So there could be, if it's an object-oriented language, there will typically be some kind of object that has an HDFQL execute method that you can invoke, and you can dynamically construct a string or take a string literal that represents a HDFQL expression, a query, and then you basically execute that. And yes, then you have to think about, well, if I have an array in my language, for example, that I would like to use as a buffer to receive data from the query results or provide data for an insert or update operation, you need some plumbing for that, but he solved all that, I think, pretty well. And so the good news is then you are in a situation where you basically have the same guest language and you can reuse those queries easily across many different host languages. And then you have the host language embeddings that sort of make it all work. Now there are of course more sophisticated things. This is not new. I mean, in the old days, people created things like embedded SQL. Then sort of in the .NET world, people created language integrated query and things like that. He didn't take it quite to that level, although that's really just a question of your budget. But I think he found a very nice middle ground to deal with these different host languages. And I have links at the end of this presentation where he has a pretty extensive collection of examples where you can judge for yourself if that integration was executed well, in your opinion. And finally, he also supports parallelism. We will talk more about things that he supports later, but parallelism in at least two senses. Number one, in a sort of nowadays multi-core environment, wherever there is opportunity for sort of thread level parallelism, he takes advantage of that, but also in the sense of MPI parallelism. So if you have an MPI program and you would like to use HDFQL with that, that's also supported. Okay, who is using it? Again, you can go back to the HDFQL website. This is just sort of a very brief summary. Definitely universities, research centers, there are companies in biotech, in renewable energy, but also increasingly in the automotive industry, in particular, electric vehicles, and then plenty others. And then I'm sure if you want to know more details, you can contact Rick, and he's a very responsive fellow. Okay, so how does it work? So this guest language actually takes on 4 different roles, if you wish, and they are described here. So, and that's nothing new. I mean, SQL does that, or sort of other SQL dialects do that for their respective data models. You use it as a data definition language, or DDL, and in the case of HDF5, that means you are creating files, you are creating groups, you are renaming data sets and so forth. You use it as a data manipulation language to insert objects, like adding records to a table in double quotes to a data set, or update the value of an attribute. You use it as a data query language to sort of retrieve information from a data set or attributes, but also to discover, let's say, the structure of an HDF5 file or multiple HDF5 files. And he also calls it as a data introspection language, where you learn something about the layout of a data set, for example, if it is compressed, what kind of compression and so forth. Here are some simple queries that just give you, and again, I would refer you to the website to see a much more extensive collection and more sophisticated examples to just create a file. Then I mentioned MPI-based parallelism already. Certain operations there need to be collective, and this is how you would do that for the file creation, for example. You can create groups, obviously, data sets, and at the same time apply a compression filter like gzip. Then on the data manipulation side, of course, there is an insert operations where you can just insert values, sequences, literals, representing certain types. But then also, I think he introduced that in the latest version, there's a very nice integration with external file formats, starting from simple text-based files and CSVs, but also in the latest version, he introduced the support for Excel. And it's much more sophisticated than what's shown here. Of course, in Excel, you have this concept of a workbook and worksheets and so forth, and there is syntax to do all that. In HDF5, we also have sort of raw chunk operations, and that's also supported in HDFQL. And then the interaction sort of with in-memory primitives like arrays and so forth in host languages works through these slots, and there is this memory keyword, and you can register different arrays in different slots, so to speak. And this is what the syntax is for this. And then, of course, there's sort of the typical hyperslab syntax and so forth. Finally, yeah, to query things, well, I guess for anybody who has seen a SQL query, there are no big surprises here. Again, with some nuances around supporting direct chunk IO and then interacting with memory array primitives in the host language. And finally, then sort of the introspection, where you can just show everything. And then there is support for regular expressions, where you can sort of trim down, you can narrow down the search, the path on the path names or on the data type of the objects that you are interested in. What's supported currently? Well, first, what kind of host languages are supported, and that's currently C, C++, Java, Python, C#, Fortran, and R. And the platforms are all the major platforms, meaning Windows, Linux, and macOS. We mentioned already direct chunk read-write support. Both types of selections, meaning point selections, hyperslab selections, are supported. Parallelism, in the sense of MPI-based parallelism, is supported. And then, yeah, interaction with external data files, such as text files, just unformatted binary Excel files, and so forth, and many more. What's on the drawing board? Sort of what's next? He is, I believe, currently HDFQL is based on HDF5 1.8.22, and he definitely wants to make the move to a 1.10 based HDF5 release to support several new things, including virtual data sets, Swimmer, to support dynamically loaded filters, but then also to support some of the VFDs that are there in 1.10, such as, oh, there's a typo here, I apologize, it's S3, not E3. So to support object stores like S3 and the Hadoop file system HDFS. And then, of course, in terms of host languages, there is no shortage of host languages such as Go and JavaScript, and tools such as MATLAB. Continuing on what's new, of course, he's also looking into more predefined functions such as aggregates, for example, but also to allow user-defined functions, and you would get these user-defined functions from a shared library that you can load dynamically into that address space for that process or those processes. And but then also to support sort of data transfer, let's call it that, between data sets and attributes, and to transfer data from one data set or attribute into another data set or attribute, with potentially some data transformation on the fly. And so that's on the drawing board. And if you want to know more, or you have a preference, a priority, and so forth, definitely get in touch with Rick and let him know. Additional information, and I think that's my last slide. You want to carefully inspect the licensing terms, but it's free in terms of use for commercial, non-commercial use. Discuss it on the HDF forum. Support inquiries to Rick. Here's the link. Binary releases, you can download them at this link. And then this is what comes in the package. So you get all the support for all these different host languages, examples, a collection of examples, and then sort of a command line tool where even without writing any host language specific code, you can sort of exercise with your existing HDF5 files, HDFQL through this HDFQL CLI command line interface tool. And then of course, a rather complete reference manual, complete and detailed reference manual. And I think that's it. And thank you for being here. And I'm happy. I'm just a stand-in, so I'm by no means an expert on HDFQL. But if you have questions, I will try to answer them.
Thank you, Gert. We have a few minutes for questions before our next talk. Please unmute yourself and ask, or type question in the chat window.
So, yes, so there is a question here about impact on performance. Yeah, in conversations with Rick, I believe I raised a similar question, but according to him, and I have no reason to doubt that, the impact is minimal. Especially if you think about, for example, yes, the interaction with buffers. For example, you allocate buffers to retrieve results into, or depending on the language. So the JNI interaction in Java, for example, might be a little different on how you would do that in C, C++, or in R, and so forth. But according to him, the impact on performance is minimal. So you get nearly the performance as handwritten code.
Thank you. There's a comment on H5 on PyTables.
Yeah, good point. I have not definitely something to bring up in the forum, for example. I'm sure he has a response to that. Right now, yeah, he takes the HDF5 files as they are. So in the case of PyTables, I'm sure it wouldn't be too difficult to implement, to discover that, first of all, this is a PyTables file, and then the indexing structure. And so, yeah, interesting idea, but yeah, I can't speak for him and his plans. If he's planning to add HDF4 into a file system cache before being read, I do not know that. You would have to ask him. I know that he is working on, for example, and the current HDFQL version already supports multiple files to a degree. So you can have a directory, and from HDFQL, for example, access files in a directory structure, and you have, with regular expressions and so forth, some control over including or excluding some of them. But again, I would defer to him to speak to that. Do you know how it uses multiple cores? Is it built? No, it's more about just using multi-threading if there are transformations involved, like using like a BLAS LA pack type library that has multi-core support built in, and then when he calculates a certain aggregate or something like that, then you take advantage of multiple cores. Not so much so that thread level parallelism is not meant in the HDF5 sense, because we all are aware here of the limitations that HDF5 has with respect to multi-threading. Does it use MPI internally? No. I think you have to be through this parallel keyword. So if you want to use HDFQL in an MPI context, in an MPI program, you basically tell HDFQL through this parallel keyword that this is a collective operation, or an operation that is to be done in parallel, and then HDFQL will do the right thing.
Okay.
Yeah.
And actually, we should prepare for the next talk now.
Yeah.
Gert, if you can
Yes,
stop sharing. Thank you very much.
Sharing.
And thank you for interest in this talk. We will try to invite and convince Rick to present.
Yeah.
We will convey to Rick and publish them on our website. So